Assalamualaikum, my name is Muhammad ZULKIFLE and now I will begin my part of presentation for our group assignment. As you can see, this is our circuit for this group assignment, and this is our non-sinusoidal waveform. And from this circuit, we gain the T, which is 2, the A, which is 9, the omega naught is 2 pi over T, and which then we gain the value of pi. And so for the first step, we will begin our Fourier series calculation to find the A naught, which is we then get the value of 4.5, the AN, which is the value is 0, and finally the BN, which is the value is 18 over n pi. So from these values, we get the Fourier series expression of ft equals to a naught plus n equals to 1 to infinity an cos omega naught t plus bn sin omega naught t. So then we gain the value 4.5, 18 over n pi sin n pi t, and n equals to 2k minus 1. So for the next step, we find the in amplitude phase form using the expression for n1, n3, and n5, which we get the value of for n1 is 18 over pi, negative 90 degree, for n3, 6 over pi with the angle of negative 90 degree, and n5 again the 18 over 5 pi with the angle of negative 90 degree. So for the phase n is negative 90 degree, phase 3 is negative 90 degree, and phase 5 is negative 90 degree. So the next part is to find the voltage. So using this equation, Vs T equals to 18 over pi n with the angle of negative 90 degree. We can find the total voltage by by combining all three values from n1, n3, and n5, which will then gain the value of this expression, which is 5.72 cos pi minus 90 degree plus 1.9 cos 3 pi negative 90 degree plus 1.15 cos 5 pi negative 90 degree. So that's all for my part. Thank you.
Hi, Assalamualaikum. My name is Muhammad Faidz Farhan ROHAIDZAM and my metric number is DE220084. So now I want to explain how to find the current using current divider rule method. Okay, so now the circuit in T domain. So now you need to change the T domain to S domain circuit. Okay, firstly XC is capacitor. So XC equal, the formula XC equal 1 per JWC. J 2 pi, W is frequency, C is capacitor. So 1 per 2 pi divide 60 Hz divide 0.25 capacitor equal 10.6 divide 10 milliohm. So for inductor XL equal JWL. This is the formula JWL. So J 2 pi divide 60 Hz frequency and divide 2 equal 753.98 ohm. And for ZR resistor is 10 ohm. So ZC is equal 10.6 milli angle negative 90 degree ohm. And for ZL equal Z equal 753.98 angle 90 degree ohm, and ZR equal 10 angle 0 degree ohm. Okay, so now you need to for ZL parallel ZC. For the answer we get negative J 10.6 milli for the angle, complex number angle 10.6 milli angle negative 90 degree. The formula Z total is ZR plus ZL parallel ZC. For the answer we get before this, 10.6 milli angle negative 90 degree. So the answer we get 10 minus J 10.6 milli. For the complex number angle, 10 angle negative 0.06 ohm. IT equal VS over ZT. So we get the answer 0.899 plus J 0.0125 milliampere. And for the complex number angle, IT equal 0.9 angle 0.06 milliampere. Formula I1 is ZC over ZL plus ZC divide IT. So we get the answer 12.653 micro. So this is answer for I1. So after I1, we need to find the I2. For the I2, formula IT minus I1. So the answer we get is 0.9 angle 0.06 ampere. But this is using the current divider rule method. But also we can using the Fourier series method to find the current. For the Fourier series, we get the same answer like the current divider rule method answer.
Now I will explain on how to find the power absorbed by the capacitor. Firstly, we need to find the Z total. So our Z out, which is inductor parallel with our capacitor, we will get the answer which is 4S over S power of 2 plus 2. This is our Z out. And our Z total we plus with 10. And then we apply the voltage divider rule to find the voltage out. So the formula is V out equal to Z out over Z total multiple with Vs. So we insert the values Z out and Z total, and we get the answer which is 2S over 5S power of 2 plus 2S plus 10. After that, we can continue to find the voltage out based on our formula that been formed, which is for N1, V out 1, our Vs1 is 18 per pi with the angle negative 90 degree, and then the value of S we need to change with the formula of this. S equal to J omega naught N. Our omega naught is pi, so our S will be J pi N. So we change all the value S with J pi N, and we get the V out 1 which is 0.9035 with the angle negative 170.93 degree volt. Same goes for V out 3. We can continue and multiple with the Vs3 that being calculated, which is 6 over pi with the angle negative 90 degree, and we get the answer which is 0.083 with the angle negative 177.51 degree volt. While for N5, which is V out 5, will be get the answer 0.0294 with the angle negative 178.53 degree volt. So this is the equation form, general form for V out in time domain, based on our calculation that been calculated. And then we can continue to find the current through the capacitor. So we use the formula KCL, which is V over Z. So for N1, V out 1 over I1 equal to V out 1 over 4 over S, which is our Z. And V out 1 we have been calculated, and then for over S we need to change with J pi N, and we get the answer for I1 is 0.7096 with the angle negative 80.93 degree. For I3, we repeat the step, so we can find the value of I3 which is 0.1956 with the angle negative 87.51 degree ampere. And lastly, for N5, we get the answer which is 0.1155 with the angle negative 88.53 degree ampere. So we can continue to find the IDC. IDC, the formula is VDC over Z total. So our Z total is 10.01 ohm and our VDC is 3 volt, and we get our IDC is 0.3 ampere. After we calculate all the component, we can create the equation, the general form for I out in time domain. For this is 0.3 as DC component, and this is for the AC component that being calculated. Lastly, the last step is we can continue use the formula of power, which is VDC multiple with IDC plus 1 over 2 sum VNIN cos with angle voltage minus angle current. So our VDC is 3 and our IDC is 0.3. So our VNIN is based on our calculation. Same goes with the angle. So this is for N1 where the condition is N1, and this for N3 Vn will be like this and In will be like this. Same goes with the angle. And for N5, so after we calculate, we have been determined that the angle will be negative 90 degree. So cos negative 90 degree will be 0. So the AC component will be 0. So only DC component that we have, which is 0.9 watt. So the power that absorbed by the capacitor is 0.9 watt. So that's okay. Hi, now I will explain on how to do the simulation for our circuit. So we are decided to use multisim as our platform to simulate our circuit. So firstly, we can find all these components, which is resistor, inductor and capacitor at here, which is place component, and we can search at here resistor or inductor or capacitor. After that, we change the value of resistor, which is 10 ohm, inductor 2 Henry, while the capacitor is 0.25 Farad. So to change it, we can double click at the component. So after that, we insert our value. So after that, we can choose our source. So our source is function generator. We can find it here. And then we set our function generator as our source. We double click, which is our frequency is 60 Hz. Our duty cycles is 50%. Amplitude is 9 volt, same as our manual calculation, which is 9 volt. And then offset is 9 volt. So it will shift up to be same as our manual calculation. And do not forget, choose our waveform, which is square wave waveform. After we set the values for each component, so we can connect it with the multimeter. Multimeter we can find it here. So as we know, if we want to use or we want to find the voltage, voltmeter must connect it in parallel with the load, while for the ammeter we must connect it in series with the load. So we run our simulation. So we can find it here. Our current, which is I total, is around 900 milliampere, while our voltage is 9 volt, same as our source. And then our V2, which is at inductor, is around 32 millivolt, and our current is around 66 microampere. And our current I2, we can find it here, which is 900 milliampere, and our voltage out, which is at the capacitor, is around 8.941 millivolt. So as we know, in parallel, voltage will be same. So as you can see here, voltage at inductor and voltage at capacitor will be same, which is 8.941 millivolt. So the another method, if we want to determine the values for current and voltage, we can set up at here, which is simulate, analyze and simulation. And then we choose single frequency AC. Our frequency is 60 Hz. Complex number is magnitude per phase. And then we run our circuit. So at here, all the values we can see, which is V1, V2, V3 and V4. All this number we can see at here. V4 is considered is V1, V input, V source. And then all this value we can put into our report and compare it with our manual calculation. So that's all from me. Thank you.